I am going to give a brief overview of the program, what we will do. So, as I was saying, the objective of this program is primarily to uh, address the maths of AI. It will start with that, but once we are done with certain maths fundamentals, we will move on to doing different aspects of AI. We will talk about machine learning, we'll talk about deep learning, then we'll talk about CNNs, we'll talk about RNNs, then we'll talk about the way transformers are made, autoencoders, variational autoencoders, the various techniques of encoder, decoder, and the transformer architecture. We'll also talk about agentic AI. We'll talk about stable diffusion, and a whole lot of other topics. And this is a multi-semester program. So we're just starting in this semester, and we are starting and targeting the first year students. Obviously, the second year students are also invited to join the program, and I think they have joined in a reasonable number. And this program will hopefully give you all the fundas needed for a good career in AI. And towards the later part of this program, we'll also look at how deep learning can be used in applications like drug discovery, applications like agriculture, applications in DNA, applications in robotic, applications in chip design. There are a lot of interesting stuff where AI is going, and the intention of this program is to get you right there and make you familiar with all that. And this program, as I think all of you know, is going to run from 10 o'clock to 12 o'clock, and we will try to run it irrespective of whether holidays are there, holidays are not there, irrespective, because it's running for a very large audience, and there will always be something or other for one segment of the audience which will need it to stop, but we will not. So we will continue. And since all the sessions are recorded, and we will soon make the recordings available either on a separate site, or we will put it on test later as support material or whatever. We will let you know how to do that within this week. So those of you who have missed the sessions can use and attend the sessions. So without too much of an introduction, I'll jump in and start the story. So I'm going to just use this lecture note. It will be also sent to you. So just going to use these notes as a help. See, first, fundamentally, you have to understand that in AI, we deal with different kinds of data. And finally, we have to work out how to convert this data into numbers. And unless we are able to convert this data into numbers, we will not be able to do much. So let me pause there a bit and give you a little insight what I mean by that. Finally, if you take today's LLMs, they use text as your input. And when they use text as an input to the LLM, when I say LLM, I hope all of you understand this is basically your chat GPT. So you take text as your input, and now once you take text as an input, basically what you do is you or somebody has to convert this text into some kind of numbers, and once you convert that into numbers, then the LLM will be able to process it. So the intelligence lies not in only how to process these numbers, but how to get the text converted to numbers. I mean, it's not just a stupid conversion of text from ASCII, from whatever the code, whatever the text code to ASCII code, and thereby look at them as numbers. No, it's not like that. It's far more complicated. So the text has to be converted to numbers. Then, the other kind of input that we deal with in AI is imaging. So the image has to be also converted into numbers. This is just to emphasize how important numbers and maths is to AI. So the image also has to be converted into numbers, whether you are using a DALI or you're using any other system to do. We need all of that. Uh, so image also has to be converted into numbers. Your voice, your video also has to be converted into numbers. All of this also has to become numbers. Uh, I mean, this is just, I'm talking about basically the common media. Then there are different kinds of text. You have DNA patterns, you have nucleotide sequences, all of that. All of that also has to be converted into numbers. Things like material properties. If you're dealing with material science, if you are trying to use AI to make gold out of copper, you need to understand how to convert material properties into numbers. So basically, at the heart of any LLM is this process of converting text into numbers, image into intelligent numbers, voice, video into intelligent numbers, DNA into intelligent numbers, nucleotide into numbers, material properties into numbers. This process has a very nice name. It is called embedding. So one of the fundamental ideas of AI is to understand the process of embedding knowledge, to embed data into numbers which are intelligent. Now I'll say this in a few minutes. What do I mean by making numbers intelligent? I'll just say that, and then I will give you a little more insight into what I mean by converting them into intelligent numbers. Okay, let's go forward and try to give you an idea about that. Now let's take the idea of king. Let's take these four words: king, queen, and man and woman. So let's just take these four words. Now this has to be converted into a number. Okay. This has to be converted also, queen also has to be converted into a number. Man has to be converted into a number. Woman has to be converted into a number. So let's call this number as N1, N2, N3, N4. Now, when I say converting into numbers, I'm obviously using the word embedding into numbers. So I've decided to embed king into number M1, queen into N2, or like that. These are all numbers, and this process is called embedding. Now, how should the embedding be smart? What do you mean by smart embedding? And there is a lot of AI which goes into converting this. Now, what does it mean? Now, as a simple, very simple thing, if I were to subtract N2 minus N1, and let's say I subtract these two, right now I'm calling them numbers, but soon I'll start calling them vectors. Okay. Right now I'm calling them numbers, but I'll come there. So if I subtract N2 minus N1 and subtract N4 minus N3, these two kind of have to be similar. If I can make them similar, and if I can say, I will not say this is exactly same as this, but I will say they are kind of similar. This difference, this whatever value I get here and whatever value I get here, which maybe I'm talking right now at a very scalar level, but I'm soon will expand that definition. Now this kind of value V1 and this kind of value V2, V1 will be more or less equal to V2. I will not say exactly equal, because obviously there are certain characteristics of man and woman which are different from king and queen. For example, king and queen have a lot of money, so that V1 will not capture that. V1 will capture that, whereas V2 will not capture that, because man and woman do not have attributes like money, kingdoms, all of that. So that attributes will not be there in V2, but they will kind of be similar. That is what it means. Just to illustrate this idea of converting data into numbers a little further, I will give you another example or another analogy. Let's say Delhi. Okay, Delhi is converted into a number. Okay, because Delhi has a lot of things. Delhi is a city, plus it's a capital of a country, all of that. So the number into which it is converted has to capture all of that. So let's call this number D1. And let's say, I capture, let's say, Hyderabad. Okay. And I capture Hyderabad, and Hyderabad has a number. Let's say DH. Okay. Uh, this is a number associated with Hyderabad. Why am I seeing this here? So I'm having this number D1, and I'm having this number DH. This is the Hyderabad number, and this is the Delhi number. And now that I have these two numbers, I'm just going to give you an analogy. Let's take Beijing, which is, as you're aware, the capital of China. Let's say this is B1. The number associated with Beijing is B1. And then the number associated with, let's say, Shanghai, which is another city in China, is S1. Now, again, the number which is associated with Beijing is B1. The number associated with Shanghai is S1. And when we do embedding correctly in AI, and we understand how to do that well, this B1 and this S1, and this D1 and this DH, let's say, or whatever. I'm just giving some notional names here. Don't worry too much. So B1 minus S1 should be more or less similar to D1 minus DH. You know, this is what I was trying to imply. Because see, Delhi is the capital of the country, Hyderabad is the capital of a state, Shanghai is like that an important city and a capital of an important province, and Beijing is another city, capital city. So basically, if you subtract that, you're kind of coming near that number. So these numbers have to be done very intelligently when you convert text into numbers. Now, we normally call them numbers, but I'm sure by now you would have figured out that a number is not adequate to capture all of this. I should not convert it into a number. I should convert it into a vector. Rather than converting text into numbers, I should attempt to convert text into vectors. Now, it is typically, that is what is done in today's AI, in today's deep learning. We don't convert text into pure scalar numbers. We convert them into vectors. Your king doesn't get converted into a number, but it converts into a vector. So vector, let's call it, this is the vector. These are values of the various dimensions of a vector. Now, what is the size of this dimension, or the size of this vector, or the number of dimensions of this vector? They are ever growing. If when ChatGPT 3.5 was introduced, this vector was 4K in size. That means there were roughly about 4,000 dimensions in the vector. Now, I hope you understand when I use the word 4,000 dimensions in a vector. Like if you have a 3-dimensional vector, you have only talking of X, Y, Z. This is a 3D vector. Now, I'm not talking of a 3D vector. I'm talking of a vector whose dimensions are 4K. So in place of X, Y, Z, there are 4,000 dimensions. I'm not going to give you labels also, but there are about 4,000 dimensions there. And these 4,000 dimensions are enough to capture the varieties of all the variations, all the nuances of the meaning of king. Now, why do I need so many vectors? Well, the bigger this number of vectors, or the larger the dimensions, I'll capture more information about that word. I think you will agree that if I have X and Y only, I have only 2-dimensional data. If I have X, Y, Z, I have N 3-dimensional data. Obviously, even a simplistic mind will say that 3-dimensional data is better than 2-dimensional data. So I have 4K dimensional data. You can imagine how big and how representative a sample could be. So this process of converting a word into a vector is called, as I mentioned before, is called embedding. And this embedding is a very important characteristic of all AI programs. Converting words into vectors, converting everything into vectors. Now, this has gone up from 4K to 8K to 16K as different and more, 32K. I think I have lost track of what K it is now with the chat GPT 5.0. But this is what will increase. So if you visualize, the more expressive I can get the word to, the bigger the vector I can create. Bigger the vector means more dimensions of the vector I can create. The vector becomes more representative and richer. Obviously, it is going to take a lot of memory. It's going to take a lot of space and all that. But well, that is what the cost you pay for having a more representative expression of data. Is it true with only image data? Sorry, with text data? No, it's true with image data also. So if you want to represent the idea of an image, let's say this is a king. Now I'm very poor at drawing. So this guy, okay, let's make him wear a coat and let's make him wear a crown and all of that. So this is crown, this is face, this is his very nicely embroidered tunic, and he has some very good shoes. So this is our king, and he has a sword in his hand and all of that. So he's a king. I don't know whether this really looks like a king or something else. So this is a king. Now this is an image of a king. Please understand. Now this image also in AI, we would like to represent it as a vector. Okay, even this would want to represent as a high dimensional vector, very big dimensional vector. And once we represent it as a vector, maybe again a 4K vector or an 8K vector, that is so many different dimensions represented by so many different values, one for each dimension. Once we start representing it like that, this image becomes smarter and becomes more enriched. I'm sure you will agree that if I give you more dimensions, you can describe more about the image. If I give you less dimensions, you can describe this image less succinctly, less expressively. And so obviously the game there is we need to express this in more dimensions. And the game of further of AI is what? And representation of data into vectors is what? Now I have king as a word and its vector representation, right? This is the vector representation of king as a word. Now I have the vector representation of king as an image. Now see, there are two different words. This is word and this is image. So I have the representation of king as an image, and I have the representation of king as just a word. And this is the vector representation which is derived from representing king as a word in vector space. Now, when you use things like DALL-E, I'm sure you have heard of DALL-E, which enables conversion of text to words, text to images, images to text, that kind of software. Or there are plenty of software out there, and these are continuously evolving. We call them VLMs, that is vision language models. What do we do there? In large language models only, we are just interested in converting the king into a rich representation of vector, into that vector, which I talked about earlier. When we are dealing with VLMs, that is vision language models, examples, as I said, is DALL-E is one example. There are plenty of other examples. I'm taking DALL-E because that's commonly used example of this. When we have that kind of a scenario, what do? Then we are not concerned about just representing image of the king as a vector and the word king as a vector, because we are working in the VLM space. We are now interested in seeing whether these two vector representations are kind of similar or same. Same would be ideal, but even similar is fine. So if we can make this similar, then the language, then you have achieved what we call multimodal synchronization. Okay, you have achieved what is called multimodal synchronization, because then your conversion or embedding of the king image and the king text is kind of similar, and then that is where the advanced vision language models work. So that's the whole thing. Anyway, this was basically what I hope at the end of this, 5 minutes, 10 minutes that we spent on this, I hope we have conveyed to you the concept that the idea of vectors is very crucial to the idea of representation, and all data in any massive AI system finally gets converted from wherever it is or whatever it is into basically a kind of a rich representation of vector. Now, does this happen automatically? No, there is a lot of learning, there is a lot of training which happens in this process. It is not trivial. See, the models learn how to convert this into this representation, this into this representation, and as I said, advanced models learn how to synchronize even these two people. So this is a very, very advanced learning that happens, and I hope you are able to understand this at this stage, that part of AI is focused on this embedding. Okay, that is a very important piece. And we will talk a lot about embedding and how to. We will show you how to convert various forms into embedding, and how to play with the embedded forms, how to do a cross product, how to do a combination, all of that. I think now we will return back to the original presentation, and let's see how we go back. Yeah, so this is where we are, and so I just illustrated the idea that actually I illustrated a couple of ideas. We said all inputs have to be converted into numbers at the prima facie level, at the basic level, but we also said, we talked about, can we scroll down? Yeah, we also talked about the idea of word embeddings. This is what I talked about. So we have two words, let's say a king, and that is a very small vector representation of king. This is a very small, this is a three-dimensional vector. Now remember, I have 4K vectors to 8K vectors in our current systems. A 4K means 4 into 1024. That is 4000 into 4 into 1024, which is almost 4096. That is the number of dimensions. Am I right? 4, yeah, something like that, or 8192 dimensions here, right? So that is the way. Queen is represented only in 3 dimensionals here. Okay, and then we use different kind of vector algebra in order to compare these things. So when I say I'm comparing, you could compare using how do you compare two vectors? Traditionally, whenever two vectors are there, we compare them by taking a dot product. A dot B. We take a dot product of the two vectors to find out how similar these two vectors are. So king and queen may not be so very similar, or they may be similar. There may be some amount of similarity because both are royal figures. But let's say king will be more similar to man, and queen will be more similar to woman, and a doctor and sorry, this is the other thing. Okay, let's say king is similar to man, queen is similar to woman, and that kind of similarity we can bring out. Normally, the operation that we use in vector algebra in order to find out how similar two vectors are is the dot product. And you know how dot product is defined? A1, B1, this is A1, B1, this is A1, A2, A3, B1, B2, B3, and so we do A1, B1, A2, B2, A3, B3. So that is how we measure the dot product of multiple vectors and see how the vectors are similar or different from each other. So this is what is called vector algebra, and dot product is common. Now you know that this stands for AB cos of theta, where theta is the angle between the two vectors. So if you have two vectors, this is the angle between the two vectors is theta. So this is sometimes, that's why this kind of similarity of doing a dot product between the two vectors and finding out the similarity, sometimes this is called as the cosine similarity. This is a word you will hear very oftenly used in AI. The word is called cosine similarity, which is meaning cosine similarity is another word for saying that I am taking a dot product between the two vectors and measuring the magnitude of the dot product. The larger the magnitude, the more similar the vectors are. The smaller the magnitude, the more different the vectors are. Okay, so let's move on. So this is what we call embedding. This we kind of talked about at length earlier. So let's proceed and understand something more. Okay, so this is the similarity of king and queen, which is A1, B1, A2, B2, all that. Okay, so let's go on. And how would you do this programmatically? Now this is for people who are new to Python or anything. Another purpose of this program is basically to help you understand Python at a conceptual level. I'm not going to use this program to teach you Python from how to write a loop and how to declare a variable and all that. That I'm going to leave it to you to figure out. And I'm sure the guys who are attending this program are smart enough to figure out how to do that. So here is something which I would like you to understand at a again very basic level. Import numpy as numpy. This is like a library. This is how you would do in C as hash include, or in Java as maybe import itself. So this is the library which we are importing. Numpy is a very popular library, stands for numeric Python, where you do a lot of numeric operations using Python. It is called numpy. So import numpy, and this is a small name we give it to it. We could always say numpy.array, but then I would have to spend a lot of time typing. So I say import numpy as np. This is my synonym. You understand the word synonym. It's my name which I am giving to numpy. So in my program, the numpy library will be addressed as np, and that makes my life easier because I have to say only np. And now if I were to represent king as a vector, I would say np.array, and this would be the way I represent the vector. Please understand, a vector in Python is represented by square brackets, the vector values separated by indices. I think those of you who are new to Python should pay particular attention to this, that this is how I would represent an array, because an array is a way Python would call a vector. It's an array of numbers, so it's a vector. So np.array. When we come to other packages, like we will introduce special AI packages in this course, like PyTorch and all, then we will not represent it as an array. We'll represent it as a, we'll use the word, not a vector or an array. What word we'll use? We'll use the word as a tensor. Okay, we'll convert our word to tensor, and then we'll tell you what is the difference between a tensor and a vector. But that will come much later. It's not the agenda right now. So right now we are just creating king as a vector of values which represent the embedding of the king in multiple dimensions, because we want different attributes of king to be captured. And how do you convert this king into vector? That is called the embedding. How did I come out of these values? How do I know a king should be 0.2, 0.8, 0.5? That is called embedding, and generally it is learned by training the system on a lot of data. This embedding is learned. Okay, so let's not get too carried away with that. Let's just understand that we know these values, the vector that king represents, but we are just representing it programmatically like this: np.array, and this is the vector. Queen is again np.array, and this vector. This is the vector representing the queen. And if you want to do the measure the similarity, we have to do a dot product or the cosine similarity. And so what do? We say np. Np is the library on which we create a function called dot. Remember, the array is also declared by saying np.array, and here we are asking for some function. Dot is a function, and so the way of creating an array and the way of creating a function or invoking a function is the same in numpy. Very, very interesting, because Python does it all the time. This is actually creating a data structure, creating a data, and this is actually calling a functionality. So if you see, it's one and the same way. When I'm creating the data, I say np dot. Only thing I there, when I'm creating data, I say np dot array. When I'm using some functionality, there could be many such functionalities, many such things which I can do with numpy. So I say np dot dot king and queen. King represents this vector, queen represents this vector, and it will automatically compute the dot product and sum it up. What you just saw earlier, that is, it will multiply this, multiply this, multiply this, and sum it up, and return that to me as similarity. The larger this value, the larger is the similarity between king and queen. The more the value, more is the thing in. So this is how you measure proximity or similarity. Some people call it proximity between two vectors, or some people, because when we are dealing in a vector space, we tend to use the word proximity or proximal. We use the word proximal or distal. Proximal when the two vectors are close, distal when the two vectors are away. And so this is how we say np dot dot king queen, and we measure the similarity. They're very simple, right? So now I hope you have understood what we mean by similarity, and now let's proceed further. Again, I am going very, very slow. Some of you may find me boring at this stage, but bear with me. It soon gets interesting. Yeah. Well, search engines, chatbots, or chat GPTs, all of them use this kind of a thing to find out which words are similar. Okay. Now we are dealing with image data. So you have an image. So this is a grayscale image. We are trying to represent a grayscale image. And now that we have a grayscale image, it is just having black and white. Black is 0, white is 255. And these are the not RGB, these are the values. And these are the intensities of an image. See, it's represented, if you notice, row by row as a two-dimensional vector. See, I've represented this as a two-dimensional vector, because an image, or I will not say image, this is an image, let's say big image, and this probably represents a patch on that image. This is a patch on that image, which is represented here. Okay, and this is represented by 0. 0 means there is something black here. This is all black, let's say. And then 128, it's kind of gray. This is kind of white, and you can understand white. Why white? Because 255 is white. So this is a patch, and this is how it is represented. Now I hope you're getting the hang of this. This is a two-dimensional array. You see this? There is a square bracket outside to represent the whole thing, and each row of this patch, this is the whole thing. This is one, and then each row is represented as a row, and that row is this data. That is, this row of the patch is this data. Okay. Similarly, this row, the next row is this data, and last row is this data. So this is how it is represented. And again, this is a standard way of representing, and it has been the way of representing for quite some time now. I'm sure many of you who are familiar with image representation would have seen this. In an image recognition problem. Okay, so let's take why is it important to represent images as numbers? Let's as vectors. I will say this is also a vector. Only thing is, it's a slightly bigger vector. It's a 3 into x vector, and it's a bigger vector. Now, what is the value of images in AI, right? And why should we represent these patches as these kind of thing? So let's talk about it a little bit from a slightly different angle. Okay, so let me just go a little forward and talk to you about images in AI. So I have, let's say, a nice image of a particular scene this is where my drawing becomes very bad. Okay, so I'm going to pretend that this is the Charminar. People will laugh when they say this is Charminar. Okay, let's pretend this is Charminar. Okay, this is an image of Charminar. Okay, now I want to train. I want to see how my system, which is trained to recognize images, goes about recognizing this photo. I show this photo, the camera takes this photo, and it wants to say, my AI has to read this image and say it is the image of Charminar, right? So how is it going to do that? Now, for that, we normally use things like convolutional neural networks, okay? Also called CNN. Please don't worry about what you need to know about it. I'm going to go talk a lot and lot about CNNs. I like CNNs a lot. So there are convolutional neural networks. They basically enable me to see this image. You can think CNN is like my eye, which sees this image and tries to convert or understand what is going on in that image. That is, I have to recognize this is Charminar. And that is the job of the CNN. Now, how would it do? Okay, so what it would do is it would first convert this image into numbers or vectors. It would convert this into, I would say, as you have seen, two-dimensional vectors. It would convert this into two-dimensional vectors. So the whole image would be represented as two-dimensional vector, which is possible to do it. Each of these inner vectors would be one row of the image. This is one row of the image. This is another row of the image. Another row of the image as zeros and ones, the pixels we call them, zeros and ones on the image. So it will capture the entire image as a collection of rows. It will do that. And this will be the vector I'll get at the first level, a 2D vector of values which are ranging from 0 to 255, as you just saw. You had values of 0 to 255. So we saw those values. And we will take that image, and now the CNN will get to work on those images. You know what it will do? It will first look at small patches of the image. So this is a big image. So it will understand what this patch, this patch, this patch, this patch, this patch. So it will convert this whole image into a bunch of patches, rectangular patches or square patches. Really doesn't matter. Often they are square patches. It will read each of this image, convert each of this image into small patches, or the big image will be converted into small patches. And once it so the CNN will have multiple layers. In the first layer, it will convert image into patches. It will break up the image into patches, and then it will take each patch and convert each patch into some kind of a vector, internal vector. This is not the vector which you see here. It will take each patch, that is each patch, this patch, take this patch, and it will convert this patch into one number, n1. Well, not number, we are beyond numbers. It will convert this patch into a vector, okay, with multiple dimensions. It will take this patch and convert it into a vector, okay. Like that, it will process each patch into vectors, okay. After that, so it has taken, first converted that into patches, and then each patch into vectors, okay. Again, what kind of vectors? It may be two-dimensional, or it may be even one-dimensional. It may be condensed. This whole patch may be represented as one-dimensional vector. I hope you understand when I say one-dimensional vector. It need not be two-dimensional, or it could be n-dimensional vector, okay. So it would be a vector. Each patch would be converted into vector. Then it will do what is called some kind of algorithms will work on these vectors, some kind of multiplication, division, some kind of equations which will be figured out on this vector, and these equations will refine these vectors further and further, and finally, at the end, this will happen in multiple ways. Okay, let me just give you a little heads up. So I'll convert each patch into a vector, and that vector will go through an equation. It will produce one intermediate vector, okay, v2. That v2 again will go through an equation, and it will produce another intermediate vector, v3. So as you go further and further in this network, okay, uh, I hope I'm able to make you understand, but I'll try again. I'll start with that big image. I'll break that image into patches. Each patch I'll convert into a vector. Think of it as a single dimensional vector. And on that vector, I'll apply some equation which will do something to that vector. And then it will produce another vector. And that vector, again, I'll give it to another equation. It will produce another vector v3, and this will keep going on till I reach a point where I have distilled through these equations so much of the knowledge of these vectors that at the end I will come to a point where I can pronounce my output. I can say, oh, this is Charminar. Okay, because these equations are very smart. They are learned over time. Okay, they have been learned over time by seeing a lot of images, a lot of data, a lot of other things. These equations are very, very smart, and our whole focus of AI will be how do I design these equations which take one phase of vectors, convert them into another better vectors. Those vectors are taken, another equations are there which will convert them into better vectors, refine the vectors further and further and further, till at the end of that pipeline, I'm able to say that this is Charminar. So these equations which work on these vectors are super smart, and they understand how these things work. And they're very, very these equations will be learned, okay, and they will take time to learn, and that learning is called training. So these equations will be trained by showing thousands of images. These equations will be built and trained, and once these equations are built and trained, you throw any picture at it. These equations are smart and will convert these vectors, and the more the vectors, we say deeper is your network. That's why we call them deep neural networks, which is deep. Deep means this is going through many times. This loop is gone through many times. That becomes a deep neural network. So that's how these things work. And therefore, it is super important to understand that the images become patches, patches become vectors, equations act on those vectors, create some more vectors, more refined vectors. Those vectors again are given to equations, they become even more refined vectors. Those vectors are again given to equations, they go and go, that process goes on. And the AI guy, you as an AI engineer, you specialize in defining these equations and helping the system train these equations. Yes, so that is a skill that you will learn, that dealing with these equations and how smart you are at dealing with these equations, all of that will determine how. And this whole thing is called a CNN, a convolutional neural network. Now, why it is called a convolutional, why is it called neural network, I am not going to talk about now. We will talk about it at length during this program. This is just to show you how this all happens. So the important thing that you need to understand here is, well, just that image consists of patches, and patches become vectors. That's it. And vectors, we do some equations on it, and they become more refined vectors. Okay, so that's all that we are trying to give you the intuition at this stage. And I think now we will go back to the original presentation and take it from there. So I think we can say that this is the image. So you can see there we have written the AI applies various operations, like I told you, the various equations which do averaging, convolution, scaling. Now here we are just showing what is averaging of an image into a single number. Averaging here is just trying to predict, if I give you an image patch, how bright is that patch, in a relative way, how bright is that patch, which is called predicting the overall intensity, average overall intensity. So what are we doing? If you can see there on the screen, we are taking the patch, we are adding up all the pixel values, all the values of all the pixels. What are these values? These are nothing but intensities. So I'm taking all the intensities of the image, And having taken the intensities of the image into consideration, what are we doing? We are adding up all the intensities and averaging the intensities over the entire patch, that is 9 intensities, and giving the average intensity. So that's what we are computing now, and that is the average intensity. So this is some kind of maths which we are doing on a patch of an image. Okay, this is very common. Okay, let's move on. Okay, so programmatically, how do you do this? How do you define it? We just saw king, queen, and how do you define a patch? Well, this is again using maths and algebra and all of that. Basically, how do you do it in Python? Again, very easy, very simple to do. This is how you do it. You have np.array, and you take np.array, and this is the first row of the patch, the second row of the patch, third row of the patch. It is an array of arrays, but we still call it np array. It's a vector of vectors, as you can see, because this is an inner vector. This is the first row, this is the second row, this is the third row, and this totally is a patch. This together becomes a patch. Now I want the average intensity of that patch. Very simple. What do I do here is I just say np.mean. Mean is a built-in function, just like dot was a built-in function. So I say np.mean, just like earlier. I create a patch. This is my image patch, and I want to say what is the blurring of the image, that is the average intensity of the image. I am saying np.mean patch. I take the entire patch, that is this vector, and it produces a mean of all the things. Now how will it produce a mean? It will take all the values, and in the two-dimensional array, it will take all the values, add them up, and create what is called as a sum, and then take a mean, that is average. That's it. That is what this does. And computer vision model, which is typically what I just showed you a little while later, which is a CNN, convolutional neural network, actually does this and makes it happen. So this is what is called patching. This is how images get represented as vectors, and this is how CNN works. Okay, now there is a third. So what have we been talking about? So far we have seen text is single dimensional vector. Each word is a single dimensional vector. King is a single dimensional vector. An image or an image patch is a two-dimensional vector, and we need to be able to deal with both. Now the other skill that we need in order to deal with this is the skill of probabilities, especially conditional probabilities, probability distributions, all of that. That everybody should be familiar with and easy to understand with. So here is some English as to what probability means here. I hope, again, I'll talk at length about probability distributions, but this is just to give you a brief introduction of why probabilities we use. So this is what I have received n emails, and this decides what is a probability that that email is a spam. So that is what it means. Actually, I should have said in an email, and it is not spam. I should have put the conditional here also. That would have made sense, but that's okay. So this is from the set of emails. What is the probability that I have a spam email? It's very high in the present circumstance. Don't go by the numbers. This is 0.87, and the probability it is not spam given email is the rest. Okay, so that is what it is. So this is something not very important. This just demonstrates an if then else loop for people who are new to Python. Can you go down? So this is just showing you how to use an if then else loop. It has nothing to do with probability. So if the probability of spam is 0.87 given something, how do you write a if loop? If you write if probability spam greater than 0.5, I say it is a spam. Otherwise, it's not a spam. Anyway, that's we will have to understand Bayes theorem. We'll have to understand the multiplication rule. We'll have to understand Poisson's distribution. We'll have to understand how do you sample Poisson's distribution, how do you describe Poisson's distribution, how do you describe noise, how do you describe conditional noise. All of that I'll cover as we go forward and forward. You should be able to understand all of that. Okay, so let's go forward and understand. So this is pretty easy. That only point we are making here is we'll have to do a whole lot of probabilities as we go forward. Okay, so this is just a basic overview. So how do you want to look at AI? Okay, every layer of an AI model is just a function applied to numbers. I would say, rather than saying numbers, I would like to say it's a function applied to vectors, because I think vectors is a far better way of saying this, rather than just saying collection of numbers or numbers. So the typical operations that we do is what is we do in vector algebra, or what we learn in vector algebra. That is, the operations are related to addition, multiplication, exponentiation, division, all of that. And without these mathematical foundations, we would not have word embeddings, which could be compared. You have a lot of maths when you convert a word into a vector. You also have a lot of maths to take a vector, which is an representation of an image, maybe a two-dimensional vector, and you have to do a lot of maths on it to convert those vectors into more complicated, more refined vectors, and still more refined vectors using equations. Then only images can be recognized. And obviously we have to deal with a lot of probabilities and predictions. So all of that. So basically the ability to deal with equations, vectors, and probabilities is the foundation of AI. That's basically the thing which we wanted to emphasize. That's all. And we'll go deep into everyone. Okay, so let's go forward. So arithmetic is not just basic math. It is the core language of AI models. By mastering it, that is mastering vector algebra. I wouldn't want to use the word arithmetic too much, but I would rather use the word of vector algebra. See, a lot of people think of AI as magic. Some of them think of AI as Bhanamati or black magic or something like that. There is nothing magical about AI. It's all about maths, and maths which is trained on maths and equations and probabilities. You have these three things controlled. There's no magic in AI. Anything can be created, any equation can be understood, and that's what we'll endeavor to do. Okay, next. Yeah, so this is the overall introduction to the course. Now you'll say, I'm talking about the course at this stage when I already talked about a bit. Yeah, so this is the week one. We will be writing some functions. Let's see how we proceed today, because it's the first day. We'll talk about polynomials. We'll soon talk about equations. And then let's go down. We'll learn some Python skills also. Then we'll focus on linear algebra. Yeah, come down. And cosine similarity and all of that. And then we'll understand determinants, eigenvectors, eigenvalues, all that. Come down. And then we'll understand Python concepts, integration, optimization, differentiation, what is convex, what is concave, what is non-convex rather. Next. We'll also spend time understanding probability. Yeah. Then we'll understand combination of probability and statistics. Then we will do a bit of statistics and data analysis. Then we'll understand the concept of gradient, all of that. And next we will, yeah. So that is going to be the pattern. And after that, we will launch, after this week 9, we will launch into the big AI, and we will start again at the basics and travel further. Okay. So before that, we will just talk on maths. Okay. Next. Okay. So we will just turn our thing to a little different. Okay. Just give us a minute. We'll pull the right code. So imagine that. So I'm going to just show you some basic Python and hope that you'll be able to do some basic Python with me. We're just going to do a little bit of Python because we've done a lot of talking. Okay, now here is a bit of Python. Now, how do you define a function in a Python? Let's say the function is, I want to define f of x as equal to, let's say, x squared plus 2x plus 5. Okay, I want to do this in Python. I want to take x as an input, compute this, and produce an output which is equal to this. So to put it very simple, since this is the first class on Python, I want to take x. I want to create a function. This is very important because I want you to understand how to create a function, and that function will take x as a parameter, and it will produce this. Okay, this is some kind of a quadratic. So how do I define a function in Python? I use the word def, and I can call the function by any name I want. So let's call this function as quad, and I can take any parameter I want. Now in Python, it is not mandatory to create the data types of parameters, and I have to put a colon here. That is to say, in C and other languages, you would put an open bracket here. So this is how I would do it. And then I would give a little bit of indentation here. I can't put the body right under def. I generally use a tab here, the tab to move forward. So I say quad of x. Then I would say, what should this quad of x is this function, the quadratic of x. So I say return. How do I put this in Python? Python provides me a nice exponentiation operator. So I say x exponent 2 plus 2 into the x plus 5. Okay, so this is how I would write this equation for Python. I would write a function. This is how I would create a function in Python. This is the first part. Okay, I don't think this requires too much of help because most of you who are even in first year can figure it out. I am creating an equation. Sorry, I am creating a function. How do I create a function? I use the keyword def to create a function. Then the name of that function is quad, and I say x is the parameter. I put colon. But I don't put things underneath it because Python needs the body to have an indentation compared to the definition. So this is the indentation. So I say return x exponent of 2, 2 times x plus 5. This is what is the value this quadratic is supposed to do. So I have that in my program. So I have defined a function. Now my next thing is I have to read this x input from the user and pass that x to this quad and print the output. How do I do that? That is equivalent of scanf. If you were in C, we would do a scanf, or we would use the scanner if you are writing Java program. But since most of you would know C by now, this is the equivalent of scanf, but it's a lot easier. But you need to understand very simple. Okay, let me elaborate what is the difference between scanf for reading X and how would you do in Python, since many of you are at C. I think by now this is clear how to create a function, and after I create a function, how do I read data? In C, how would I have read data? I would have said scanf, then I would have said %d, and then I would have had a messy thing x, ampersand of x, and I would have to also put a nice semicolon here. Okay, this is how I would do it in Python. Sorry, in C. Now in C, why it's a mess? Okay, why I call C a mess is this. This is a mess because I have to absolutely know the data type of a variable if I have to use it in C. That means I have to know x is going to be an integer, and I have to proclaim that, because this is the way scanf is told to expect x as an integer. This is called the data type declaration or the data type indication. So without that, scanf can't read data. So scanf is a very stupid, old, 50-year-old, more than 50-year-old way. And see how clumsy and ugly it looks. Scanf, I have to tell the data type of X, which is %d, and then even messier is this. Why the hell should I have to pass an address? This is my address. This is my way of writing address. Okay. Again, I am very poor at representation, symbolism. So ampersand of X is the way I represent a variable, and sorry, address of a variable. Now, why the hell do I need an address? My good old scanf written in Tretayug needs the data type to be indicated, also needs an address to be indicated. And then only it can read a variable, and that's how stupid C is, right? How would I do that in in Python? In Python, I would make life very easy. Well, it depends on how you look at it. I would say, yeah. Now, in Python, the way to read data is input. But the problem is, if I read data as input, then X will be automatically treated as a string, because there is a built-in function in Python called input, just like scanf, which goes to the keyboard, reads data. But the problem is, when it reads data, it automatically converts that data into string. This is what happens in Python. But I don't want X as a string, you see. If I'm entered 2, I want 2 to be treated as a number and not as a string. So in Python, what I would have to say is, I would have to indicate the data type in this way. I would have to say int. Int is a function in Python, and input is also a function in Python. It's all built-in functions. So look at this, the way I'm doing it in Python. I would have to say input. This is to read data. This is like your scanf. And this int is like, giving the data type in a kind of a different way through a function. This is much more neater. It's saying input gives me the data in string form. So what I get is string. But since I need a number, I'm going to apply an int function on it. This is the int function getting applied on the output of input. And what is it doing? It is converting the string, which input is giving me, into a number and giving me X as a number, X as an integer. So once I get X as an integer, I'm kind of happy, because that's what I have achieved by writing this, what I have achieved by writing this scanf. This is because many of you are in first year, and we are writing it, also designing the course keeping the first year in mind. So please understand that we have read X equal to int input, and we have read the data. Now, having read the data, what do I have to do? Remember, I have already defined a function called quad of X. Now, what do I have to do? I have to say print. Okay? I'll say print because I want the output. And then I'll say quad of X. I could use some other variable also if you want. I can say Y, and I can say quad of Y. This is so that you don't get confused with the use of the actual variable. The actual variable is Y, and when I create the function, I use X. This is called the formal variable, right? This is called the formal variable. In my invocation, Y is the actual variable. So the value of Y will be copied to the value of X. Okay, we'll worry about that. And then the function is written in terms of the formal variable always. But Y takes the value of X, or X takes the value of Y, and then it does all this and returns this. And then what I do is, then I call that quad Y. Y is this is Y. I've read the value, and quad of Y, and I print. That is all I do. So, okay. I think you're logged into this tool. Keep yourself logged in here. And would you want to do this function? Let's just do this very quickly. We'll enable it on your tessellator. Yeah. You know how to go to tessellator, right? So you have to go to, this is your thing. So you open another browser window on.
They already logged into that.
They already, oh, you just have to return to your original browser window.
Yeah.
And there will be an activity there called program 1. Okay. Now we just want you to do that program 1, which basically explains how to do a quadratic. what I just talked about. This is just like a revision for you, and if you want, please do it. I would like you to do it so that when we go to more advanced stuff, we keep this habit of me talking about something, then you doing it, and then going forward. Okay, so we are also going to show you the screen. We are just asking you to do this program for a bit. So we're just starting a particular program. Okay, we're just showing you the dashboard of how the quadratic is being solved. We'll just give you a few minutes. This is because these are initial sessions, and we would like you to get used to them. Our style, very easy. You just have to write a quadratic equation and solve it. Because this is going to be a teaching come learning course, and you're going to learn a lot with us, and you're going to solve a lot with us on various platforms like Tantric, Tufan, on our GPUs and all of that. So we'll wait for some people at least to solve. We are seeing about 120 people trying. It's a very simple Python code. Just write a quadratic equation, just write a function, and that's it. Hey, come on, guys. You shouldn't take that long. Hey, come on, guys. Let's finish it fast. What a simple function shouldn't take this long. I'll wait for 150 and then show you how it is done, because it shouldn't take more than this. Okay, let's just show you how it is done. Yeah, okay. Let's just see how somebody has done it. It's so simple, so simple. Yeah. Yeah, let's look at the code. So, no, please, this is not how I want you to write. Please write a function. The way you're reading input is fine. Please write a function which does this same thing and return. The idea is to get you into the functions and may enable you to write the functions. I didn't want this. This is the right answer, but I want it as a function. Okay. Let's see if somebody has done it that way. Let's see somebody else who has written a function. Yeah, this is what I wanted. Good. Yeah, who is this? Keshav Rathi. Okay, good. So x is equal to int input quad. This is what we want. The name of the function is quad, and this is written. Those of you who are not careful, this is written with this indentation. This is pushed in. This R is not under def, but this is pushed in, and you generally tab it and come to this. So you give R equal to. You can say return. You can directly say return, or you can say R equal to something and return R. And then you say OP is equal to, you invoke the function. So this X gets passed as a parameter to this and gets, this name could be also different, and then print off. Perfect. This is what I was looking for. And okay, so let's move on to the next thing, because I can't be waiting for, yeah, just let's erase this, and yeah. Let's move on to the next piece of code in our, let's see how many finished. Okay, the rest of you can finish at leisure. Let's move on to the next one. Okay. We're just trying to do some basic stuff. So a camera has to calculate the brightness of a pixel value using the average of its RGB value. Now in this case, so you have to accept from the user RGB values. RGB stands for red, green, and blue values, and you have to create the average intensity or brightness of a pixel, which is an average of these three values. So the program should be capable of reading three values instead of one, and once it reads three values, it should take an average of those three values and do it. So basically here I'm not asking you to write a function, but just understand how to read three values in one go. And I'll show you how to do that, and then you can do it. So let's see how you do that. So this is the second program. This gives you a little more understanding of reading different kinds of input. So what will you do in this program? You'll read R, comma, green, comma, blue is equal to, now this becomes interesting. How do you do it? And let me explain what do you do. So you read input. Now input is going to be a line of 3 values. Okay, input is going to be a line of 3 values. So when you read input, because the way I'm going to give input to this program is, I'm going to say 25, 20, 25, and 30 with a space separation, right? Space separated value. This is how I'm going to give the input. This is going to be my RGB. So I'm going to read input, but when I read input, I'm going to get this whole thing as one string. Yeah. If I just say input, I'm going to get all of this as one string. I don't want that. What I want is, I want it to be split into 3 values. So on the input value, I'll say dot. This is how you do the chaining in Python. Beautiful. Input function gives me this whole string. Yeah, this brings it me here. And then on that, I call a function called split. That means on the output of input, I am calling the function split. S-P-L-I-T, S-P-L-I-T, split. When I call this, what do I get at this stage? I get 20 separate, 25 separate, 30 separate, right? I get all of that. Then now the problem is, though I have got all of that, I have got all of this as what? You remember from earlier, I have got input. This was a big string. I split it. By default, it splits on space. I split it. It split all right. Gave me 20, 25, and 30. But these are now still strings. These are still strings, right? This string. I don't want them as strings because I want to take the average of them. And therefore, I want to convert them into integers. Now, can I just say int on this? If I say int on this, it's not going to work, because int expects only one value. It can convert one value, like what we saw last example. It takes one value and converts it into integer. But now int has no ability to work on a set of values. This int is very, it's not very bright. So it works on only one value. Okay. And this is a very common problem where I have data, I split it, I've got strings. Now I want them as 3 integers. So if I want them as 3 integers, now I can't get them as integers by saying int, because I told you the limitation of int function is that it expects this value to be a single value, not a vector of values, not a string of, not a collection of values. But in the present case, what I'm having is, this is producing these 3 values, right? Each of them as an individual string, but it's a collection, like an array of that is being produced. Int won't work on that. So I have to be a little more smart. I have to use a function, which I will, I hope you have understood the problem. Now I'll tell you what I have to do. So I have to say R, G, B. Now watch carefully what I'm writing. Map. I have to use another function which Python provides. Python gives me a lot of good functions. Int, and I will say, I will explain what is happening here. Input dot split. Split is a very nice guy. And I have this. So let's just understand what is happening here. So you know what is happening here. We are getting a collection of values. Let's say 20, 25, 30, whatever. We're getting this collection of values. Now, map is a nice function which transforms whatever is given to it as a second parameter using this. It expects this as a function. It expects a function here. Int is a function. In Python, int is a function. It's a name of a function. So it applies this function onto each of these values. Okay, that is what map does. Map takes 2 parameters, the function to apply and the set of values to apply, the collection of values to apply, and applies this on each of them. So it goes to each one of them and says, Mr. 20, you're going to become an integer. Mr. 25, you're going to become an integer from a string, because split has given me as a string. And you're going to go to each one of them and say, oh, I know you are strings, but I want you as integers. So I'm going to go to each one of you and convert you into integers. So that is what map does. He's a really, really strong guy. He will go to a collection, this collection means a group of values, and apply this function on each and every member of this collection. So what it will do, this 20 will get converted into int and it will come into R, because that is how I have given this tuple of values, this group of values. Then I will say again int, this int second time will go to 25, convert this 25 from string to integer and put it in green, and then take this 30 and put it in blue. And once I have this RGB, then I have to produce only the mean color, which is equal to R plus G plus B by 3. I mean that this is basic maths, so you can do it, and then you have to print the mean color. That's it. This is what we are asking you to do. So it will give you a bit of exercise with doing this kind of stuff, and will help you translate data from one form to a form which we want. This is a very common requirement where we have 3 values. Okay, don't do it too much. When you have 1,000 values, you are not going to do this way. We are going to use a list, which probably will show you soon in one of our next examples. This gives you exposure how to deal with different kinds of data. We had scalar data, now we have vector data. Now we'll have even more complex data. This is a very limited vector data, and let's see how we do this. So again, I'm going to step back for a bit, and you are going to write some nice code to take RGB values from the user and convert it into integer, into mean value. Okay. So we are opening up another exercise for you, and hopefully you will do it. Okay, so we have moved on to the second question. Please do it, and let's see how it's happening. Okay, let's see how many. You have to move on. You have to finish just one more at least. About 179 have finished. Okay, let's see the solution for a bit, so that people who are struggling may get a little help. So here is how you write. I kind of gave you the solution. So this is what is the expected solution. You have input.split, because your input is going to come like this, you see on the screen. Input is going to come like this, 255, 255, 255. So you're going to split, and when you split, it is going to become 255 to red, 250, I mean, it's going to become 3 strings, each of one number. That is what split is going to do. Okay, and then you're going to use a map which will go to each split with this function. This is a tool which goes to each value which is returned by input.split. So it goes to this value, goes to this value, goes to the third value also, which has come from split, and goes to this third value, and it gets back 255, 255, and 255 as integers. So that comes in RGB. R becomes the 255. In this case, G becomes same, blue becomes same. Then you write a small equation, R plus G plus B divided by 3, and you have the average. So this is how you get the average. Okay, this is pretty simple stuff, basic Python stuff. Right? Sorry, let me go back and erase this. So this is how you do it. I think you should take it. Now let's see whether we have improved our number. And we will go to the next one and just do one more and stop. Okay. Okay, we know how to compute brightness, and now we will do a simple other function, very easy, for determining node music synthesizer. Adjust node frequency when moving across octaves. I don't know, this doesn't look like a nice function. Okay, we'll skip this. We'll not do this program 3. Let's I don't like this, we'll skip this. I like this. Okay, so we are going to do a delivery robot travels on a 2D grid, compute the straight distance between the 2 points. So imagine you are a 2D grid. Yeah. This gives us a little more insight on how to read data. Oh, sorry.
Yeah, you can
No.
take
I want to go back to.
on
Wait. Oh. So there is a bot, and there is a 2D grid. There is a 2D grid, and it travels on a 2D grid. So there is one point here and one point here. So I am given the 2 points as a vector. This is one vector. This is another vector. So I am given these 2 points as two different vectors, and I am supposed to calculate the Euclidean distance between them. So since it's a two-dimensional vector, basically what we need to say is that this is a two-dimensional vector, and so this will have an x coordinate and a y coordinate. Let's call this AB, or let's call this A1 B1. A1 is the x coordinate, y1 B1 is the y coordinate. Let's call this A2 B2. So this is A1 B1, this is A2 B2, this point, and we have to calculate the Euclidean distance between them, or the straight line distance as we call it. So which is square root of A2 minus A1 the whole square plus B2 minus B1 the whole square, right? So this is how you calculate the difference between these two. And it will require a bit of work on our part to get this going. We need to calculate square root, so we will need a math library. Math library is there in Python, and it's called, we'll have to import, I guess, okay, so let me try and write the Python stuff for this. Let's see if we can get that right. Okay, so we will have to say import maths is the name, no?
Yeah.
As M.
And like, they don't require as an.
Yeah, okay. Yeah. So import maths as M, and that square roots comes as part of M.
They can directly use it. Function.
They can say maths dot square.
Yeah.
Let them get into this habit.
Okay.
So import maths as M. This is a name I am going to use instead of saying maths in my code. Now what do I need? I need to be able to read the two vectors. So I can read it as a list, but I think the way the input is going to given is two lines, two separate lines. So we can read each line separately. So how do I read? So the way the input is going to given is A1 B1 on the first line and A2 B2 on the second line. This is the XY coordinates of the first point. This is the first point, and this is the XY coordinate of the second point. Correct? So we are going to be given that. So we can read it one at a time, and let's see how we can do it. So I will say A1 comma B1. Now how do I read these two? We learned that, right? So I'm going to say, working inwards to outwards, input dot split. So I'm going to read this input. So input is going to get me this whole thing, and when I split, I'm going to get this as two different parts but as strings. Then using the map, I'm going to convert it into integers. So I'm going to make the map integer go to each one of them, and work with each one of them, that is A1 and B1, and convert that into an integer. So map, does what? We just went over that. It takes this A1 and B1 separately and goes to each one of them. It goes to A1 first, converts it into integer, goes to B1 second, converts it into integer, and gives it to me A1 as this and B1 as the second value. So this will come here, this will come here. Now I repeat the same thing. A2 B2 is equal to map. Again, for the next line, I say again int input dot split, because each input is going to read one string. So this is going to read together, and this is going to read together. First time it's going to read this, second time it's going to read this. Split it and convert each of those values into integers and put it here. Now I have A1 and A2. Now I have to compute the distance. So distance is equal to, what do I do now? I say m dot square root. This is the built-in function provided from the maths library to give you the square root computation. And now I pass parameters to it, which is the square root of what? Square root of this minus this, the whole square. So a2. So I have got a2 variable, a1 variable, a2 minus a1. Those of you who are C oriented will notice that I am nowhere declaring the data types of these variables. I'm asking Python to figure them out on their own. In this case, they are integers because they are getting converted into integers. But I'm not going to say, see, it's implicit here that I'm converting the data into int. This must be an int, right? See, this is, I don't have to say like I do in some stupid languages, int a is equal to something. No, I don't need to. It is not needed in Python. Python is smart enough that if I'm converting every value into an integer, I will not get buffaloes, I'll get integers only. So a1 is going to be an integer, b1 is also going to be an integer because I asked for the data to be converted into integer, right? So I'll say a2 minus a1, the whole square, and I say the whole square like this, plus b2 minus b1, the whole square. Okay, so that's how I get it, and then I say print distance. That's it. I'm done. No, I don't need a semicolon either. So this is how I would go about doing it, and this is the program. So let's see whether you can do it. So I'm going to move on and ask you to do it. This just gives you some understanding of how to read data in Python and how to work with it.
Program is started, you can work on it, guys.
Achha, we have started program 4, not program 3. Eh? So please do program 4. Okay, about 100 people finished. See, the red bar that you see on the screen is when there is a clash of the IP address. Maybe the same IP is used to submit, or sometimes it may happen from the hostel also.
Yes.
Must be the same hostel. Same hostel or same room or something like that. But let's look at the solution, how people did. Yeah, this is how the solution looks like when we do it. Import maths as m, a1 b1 is equal to map input dot. See, I hope everybody is clear how this works. See, and this is how the split is happening. This is how input reads the line. So this whole line will be read as one string. Then it gets split, and then map goes with to each split and applies this int. This can be many other things also. You'll soon see how map gets used. And then you do the square root. Same thing you do with a2, b2. Then you do the a1 minus a2, the whole square, plus b1 minus b2, the whole square, and you get the value, and then print that value, and then that's it. So that's all that is. And yeah, I actually don't want to go further than this because I don't like exceeding time on a precious Sunday that you have. So I'm going to call it a day, but we are going to go forward. But before you drop off, I would like a bit of a feedback because this is the first time we are doing it. So can we ask 2 questions? Can we poll for 2 questions? I would like you to just respond to this poll, which will help us serve you better. First question is, you know, do you like is the audio clear, audio video clear? That's the first thing. And we would like a poll on that. So just answer that poll, that will give us input. So can somebody quickly, you will create the poll? Okay, we'll try and create a poll.
Questions.
Enter your question. First question is, was the audio video clear? Yes, no. Third answer is patchy, spotty. Spotty means not halfway there. Okay, please answer this poll fast. Save poll. And what do we do in order to? So we have launched a poll. Here I am able to see so many voted. Okay, audio video was clear. About most of them are saying okay. Spotty is 11%, 11 people, 2%. That's okay. So I think we can end this poll, and I would like you to stay back for one more quick question. Was the audio and video clear? I think 84% have voted, and 96% are finding it okay. So I think I'll close the poll. So we just
That is closed.
that is closed.
Yeah.
Yeah. Okay. Just one more poll before we close. Is the okay? The question is going to be: is the pace okay? Do you want me to slow down, or is this pace okay? Pace is the way I'm because I address a lot of audiences and I'm always not right with the audience. Is the pace of the lecture okay? It can be okay. It can be slow, or slow means I'm going slow, or fast, which means I'm going too fast. So the lecture pace is interpretation is it's okay. Slow means I'm going slow. You think I'm going slow, so that means I should go faster. Fast means I'm going fast, and therefore I should go slower. So that is the feedback. Okay, so we are saving this poll and launching this poll. Yeah, the poll is launched. Yeah, we're watching for the feedback. Okay, think a large number has already voted. Okay, just a minute. Before we could get it, our laptop this side got shut off. It will take a few minutes. Well, the outcome is that the pace, about 92% people who are available have voted, and 72% people find it 72% find it okay, 13% they find me slow, and 15% find me fast. So I'm going to assume that this is okay because a large majority, about 70%, have felt this is okay. Okay. So I'm going to say that this is okay and we'll continue with the same pace. Okay. So we will meet again next Sunday with more stuff. This was just a kickoff session. So next Sunday we'll meet again and we will continue. Okay. So hope to see you in bigger numbers next week, next Sunday. Yeah. Thank you.